Hello everyone, welcome back to Quick Coding Bytes. In this video, we will be looking at how to create and use variables to store data, learn about arithmetic operators, continue our discussion on creating functions. If you haven't watched the previous video in this series, make sure to first go through it and then come back and watch this video. The video will be in the upper right or somewhere on your screen that you can click. Now that you learned how to do input and output in C++, let's learn about variables. So in C++, the following fundamental types exist. So we have already seen one. We've already seen the int. So what an int is int basically stores a whole number. Remember, it only stores a whole number. And what it does is it truncates the decimal point. And what I mean by that is, let's say somebody tries to store 25.01, it will just throw out the decimal point and keep the whole number. So the number stored would be 25. And what truncate means is that if the user inputs, let's say 25.79, well, that should round to 26, but it'll just throw out the decimal point and just keep 25. So let me show you an example. So if I were to do, let's say, cin x, cout x. So I'm gonna start with our debugging, and let's look at this. So you're gonna go, let's say I put in 25, prints 25. Let's say I put 25.01, still prints 25. And now let's say if I print, let's say 25.83. Now this should round to 26, but again, it outputs 25. So it only holds whole numbers and it truncates the ending of the number. The next number we can talk about is, or the next data type we can talk about is float. So float stands for floating point number, which is your decimal number. If I were to change this to float, so to declare a float, you just do this. You just change the int to a float. And again, I'm taking user input of x and printing user output. So if I'm going to build this program, so by the way, to just build your program and run without debugging, you just do Control F5. It's just a handy tip. So if I do 25.01, prints 25.01. If I were to do 25.87, again, prints 25.7. So it's your standard decimal point number. So the next data type we're going to talk about is double. So double stands for double precision floating point number. It's basically the better decimal. A double precision means is that its size in memory is 2 times the one as float, meaning it's able to store more decimal points or more data in general, and it's a lot more accurate. So in general, if space isn't a concern, people like to use doubles. Again, it'll run exactly the same. Again, I did Control F5 to just run it. Let's say I do 34.78, prints 34.78. Pretty much the same way as a float, except it has more precision because it's a larger number, or has more bits to hold the data. The next data type we're going to talk about is character. So to declare character, you just do char. Character, char, char, makes sense. Again, let's run it. Control F5. And now character stores characters. So what are characters? A, B, C, D, so on. So if I do Q, it prints a Q. If I do I, it prints I. Let's say M, prints M. By the way, these are also characters, right? So in fact, all numbers and everything are also characters in programming. It's something called the ASCII table. The ASCII table represents numbers and characters. It's something we're going to go on later in this series, but just remember that characters store one single character. So that's all they store. So if I were to do, let's say, 23, I'll just print 2 because it only stores a single, symbol. Think of it as a single symbol. So that's what character stores. The next one is a Boolean. So I do talk about computer number systems, and I talk about Boolean logic gates. It's another video. You can check it out somewhere on the screen. It'll pop up. But Booleans are basically true and false, or 1 and 0. So to declare a Boolean in C++, you do bool, and it pretty much works same way. Let's say I do 2, or let's say I do 1, it prints a 1. Let's say I print 2, it still prints a 1. Now why does it still print a 1? Is that in C++, everything but a 0 is true. And then 0 is the only thing that's false. So that's how it works. If I put 0 here, it prints 0. If I put, like, I don't know, 9, it'll still print 1 as in true, because everything but 0 is true. Another note that I want to make is I've been just using X. Well, you can name it a different name, and you're encouraged to use different names. You want to make the name as specific as possible, is so that, let's say, your friend or somebody else is reading your code, they too can read your code and understand what it does, and variable names are a big part of that. But you can't just name your variables anything. The only characters that you can use in names are alphabet characters, numeric digits, and the underscore characters. The underscore character is this. Well, I'm going to get an error here. But more specifically, I want to talk about all the rules. The first character in the name cannot be a numeric digit, meaning I can't do 7. Again, that's going to complain. You can't start with a numeric digit. And uppercase characters are considered distinct from lowercase characters. So what that means is that C++ cares about capitalization. It cares if the name is capital X. So if I were to do capital X, this is different from lowercase x. So they both can take on different values. And then last thing is that you cannot use C++ keywords for a name. So keywords are special words in C++ which have an actual name or an actual thing that's represented. So for example, bool, int, a float, double, those are all keywords in C++. So I cannot name a bool. Again, it's going to start complaining. The squiggly line is a complaint. And again, I guess I can talk about this right now. If you go down to the error list, or let's say you don't see error list, you can search up error list up here and you can go get the error list, and that gives you the errors in your code. So I have a squiggly line, so it says invalid combination of type specifiers. So it's not correctly telling me the error. It thinks that I'm trying to combine two types, but essentially you cannot name it, you can't use keywords. And I talked about how C++ is a case-sensitive language, so I guess another example would be capital art and lowercase art are two different things. So now let's talk about arithmetic, or arithmetic operators in C++. So I'm just going to create x is 11, int y is 5. I'm going to write the code and we can talk about it. Cout addition x plus y, cout subtraction, or actually, let me put the end line here, x minus y, end line. I'm just going to duplicate this. And so to duplicate a line, you just stand on the line and just do Control D. Lets you duplicate. Another quick or easy to use shortcut. Multiplication and star. Let's go with division. And then one more. So this last one may be something that we may have to discuss. Modulus. Okay, let's run this. Debug. Start without debugging. So let's look at what inputs we put and the output. So addition, x plus y. Again, simple. It's just as you would expect. I put this, so in this function it automatically evaluated x plus 5, so addition of 11 plus 5 is 16, subtraction of the 2 is 6, multiplication again works the same way, use the star, and that's how they represent multiplication, 55, and division. So division is something that we can talk about because it should be there should be a decimal point at the end, but there isn't. So the reason for this is because when you divide two integer types, you don't get the decimal point. So remember I talked about how integers hold whole numbers. Well, dividing 11 by 5 doesn't produce a whole number. It's 2 point something, or 2 and 1/5. But because it's an integer, it will throw out the decimal point, so you're just left with 2. So if you wanted to save the decimal point, you would have to change one of them to a double so that C++ knows, oh, you want to keep the decimal point. So let's try to, I guess I can do that right now. If I were to change one of them to a double, or float for that matter, you're going to see that that this division, that this division is going to, well, I'm getting an error here, so I'm just going to comment it and then I'll talk about why when we first talk about this. So I just want to first show you that you do get the decimal when you do the division. So 2.2. So now since I use double with one of them, C++ knows that I do want the decimal point. So now we have to talk about this last one, modulus. So I'm going to change this back to an int. Actually, yeah, I'm going to change it back to an int and talk about why double doesn't work. So modulo is just a complicated way of saying the remainder of the division. So if I were to run this program again, or modulo, modulus is 1. Why? Because 11 or x, so 11 goes, when you divide 11 by 5, you get 2 whole, so 2 times 5 would be 10, and you have a remainder of 1, so output's 1. And so that's all it does. It just gets the remainder of the division. So why it didn't work with the double? The reason it didn't work with the double is because it needs to have 2 integers, because the remainder needs to be a whole number. It can't be a decimal number. So even though we didn't put a decimal number, it won't work when there's a decimal. So you can't do the modulo of 11 and 5.5, because then that modulo wouldn't be a whole number, and the modulus is always a whole number. So you can actually save these arithmetic operators to new variables. So let's say I wanted to create a float which saves the division of the two. So I do 11 by 5. Again, actually this is going to be an interesting conversation when I talk about this. Float x, or float c, or float f is equal to 11 divided by, or not 11 divided by 5, what am I doing? It would be x divided by y. And you're going to see that float is still going to be 2. It's because even though we're setting it to a float, because you're dividing two integer numbers, C++ thinks you don't care about the decimal point. So if I were to print float or print f, as you'll see, I'll still print 2 because C++, since you're dividing two integers, it thinks that you don't care about the decimal point. So yeah, you can set a variable equal to the arithmetic operation of two different variables or another variable itself. So we originally started declaring variables individually, but you can use arithmetic operators on them. Another one we can talk about is the keyword const. So when you use the const keyword, it basically means you can't change the value of the variable. So if I were to do this as const x is equal to 11. Now this code works all fine and good, but let's say I tried to do x is now equal to 2. It's gonna complain. And if I were to go to the error list, it says expression must be a modifiable value. So once you declare a const, you set x equal to 11. That means you cannot change it. It's not modifiable, so I can't modify it here. So you would use this for system constants. So when we talk about vectors or arrays or the size of something, for example, you may create a constant integer that you don't want anybody or you don't want to change in your program. So I guess now it's time to take a greater look at functions. So I gave a brief intro to functions last time, but as a refresher, let's talk about the main function real quick. So let me just remove this constant modifier. Yep, okay. So the main function is the first function that runs when somebody runs your code. We can define our own functions as well. So let's say I define my own function. So I'm just going to write the function and then we will discuss what it does. Whoops. Alright, so I wrote the function. So this part of the function, or let me make a comment. So if you remember from last time, 2 slashes makes a line comment. This part is known as the function prototype. The function prototype. The first int right here tells you what the function will return. So in our case, our function is going to return an integer. You can change it to Boolean, you can have your function return anything, but our function right now currently returns an integer. And let's say your function doesn't need to return anything, like our main function doesn't need to return anything. We can use void, which would represent there's nothing, it's not returning anything. So I'm going to change it back to int. So this is called the function prototype. The add 6 part is represented as the name of the function. Pretty self-explanatory. We're naming our function add6. Just going to put int as return type. So it's known as the return type. And the thing inside the parentheses, int x, represents the arguments that we're passing into the function. So think of arguments as a fancy way of saying inputs. So what are the inputs to our function? Well, we're taking an input x, so we're taking an integer who in our function will be named x. And let's say, actually I want to change this to u for a reason I'll explain later. So that's the rundown of functions. So this is called the function prototype. This tells you what the function is returning. This is the name of the function, and these are the inputs or the arguments to the function. And let's say you don't want our function to return anything. You would still have to put the parentheses. The lack of anything inside the parentheses says that you don't want, or that your function doesn't take any inputs, but you still need the parentheses there. So let me change that back to int u. Now let's try to call the function. So I'm going to go here and go int y is equal to add 6x. Whoops. And then cout y. So let me run the code. So our function return, or our program returns 17. So let's figure out why it returns 17. Let's figure this out. So this is called the function call. So basically you're calling the function there. So I declared a variable x to stand to 11, and I created y, and then y is equal to the value that's returned by the function. So when you do add 6x, what it does is it takes the value of x and pops it into u. So it creates a new variable u in memory, and plops and assigns that value to this variable. So x is 11, and an x value 11 goes to u, and then this function, using this returns an integer whose value is u plus 6, which is, in our case, 17. So that's pretty much how simple functions are. They're super easy to do, and they're really, really useful. Another thing we can do is I can do add 6, 15. So is 15 an integer? Sure it is. 15 is perfectly fine to use as an integer. So what this will do is it'll set u to be 15 and add 6 to it for the answer of 21. So to run this, yep, you get 21. Another important distinction that I want to make is something called scope. So I'm going to change this back to x and put x there as well. And let's see how I want to do this. So I'm going to create a new scope. X is equal to 15, and then cout to x. And actually, I'm going to put inside I'm gonna just give me a bit. I'm going to make sure I want to do something. So I'm going to be talking about scope here. So what scope is it's the reason why when we print this, x is going to show us two different values right here. So if I were to run this, let me do Control F5, and we see x took two different values here. The reason for this is because scope. So what scope is it's scope would be the code that's inside a group of inside a brace. So this is me defining a new scope. When you put a closing starting brace and a closing brace, you're defining a new scope. And the reason why we printed two different things is because when two variables have the same name, the variable that takes the precedent, or the value, or the variable which is actually like used by the code that's written inside the scope, is the most local variable. So basically, since x equals 15 is located locally, or it's defined inside the scope, that's the thing that's going to be printed. So it's not that this is deleted, it's that, so I actually want to prove that it's not deleted, so I'm going to take this, and this, and if I were to print this, again, you see 11, 15, 11. So the value is still 11. So because it's declared twice, or since it's inside the scope, this is going to print 15 because it's the most local variable. And an interesting conversation is that once this leaves the scope, this variable is removed from memory. The variable is only defined inside the scope or inside a group of braces. So in this example, when we return this x, so this x is a new copy of the variable. And when you leave the scope, so when this function returns, this variable is also deleted. So this can be used to create abstractions or different pieces of code which can use the same variable names, but they do behave differently. So if I were to comment this out, let's see what happens. It prints 11 three times. It's because this variable is defined inside this scope right here, meaning it's still accessible by everything that's inside this smaller scope, but so it prints x, but when you declare a local or a variable that's closer to the function or closer to the place that's using it, it'll end up using that one. And last thing I want to talk about before we return or before we close our discussion is global variables. So if I were to declare int g, or I'm going to do int x is equal to 15. Or actually, instead of 15, I'm going to make it 200. So int x is equal to 200. What does that mean? So, and I'm just going to, you know what? I'm going to return x, and I'm just gonna make this u, and I'm going to do cout at 6 0 and line. So what global variables are variables that aren't inside any scope. So it's not inside a scope, it's not inside two braces. So what this means is everybody can access this variable. And when I mean everybody, I mean all functions, everything inside this code can access that variable. So even in this function, it's not complaining, and you know what? I'm just going to run it to show you guys. So outside, I see 200, 11, 11. So now let's discuss why. Scope means everybody can access this variable, but because there's a local or variable also named x located inside the scope, it prints that variable. Here in add 6, so when you go to add 6, there's no function, there's no x defined inside this function, but since there's a global variable, it prints the global variable value. So if I were to comment this, meaning now there's no x defined inside this function either, there's only x up here, which is the value of 200. Now if I were to run this code, boom, we still see 200. Everything prints 200. So we talked about a lot here. We talked about functions, we talked about different data types, we talked about scoping, how it looks at the most local variable, and we talked about global variables. So now in the next tutorial, we're going to talk about strings, arrays, and structures in preparation to introduce classes. Stay tuned for more videos.